Hi everyone, in this lesson we're looking at applying surface area and volume to real-world applications. So far you have calculated surface area and volume for basic shapes or basic 3D objects. Then you've looked at composite shapes, and now we're looking at applying context of real-worldness to these problems. Your job is going to be solving problems associated to that. So to be successful, it's still the same concept. There's just this new additional component in the context of the problem. So just making sure that we are accountable for wastage and maybe the cost of a project. So think about it like surface area relates to paint, and how much paint are you going to need and how much is it going to cost you. So there's like that extra dimension to these problems now. All right, so your problem solving process, you should be familiar with that, is that you are going to formulate. So devise a plan. What is the question asking you to do, and what is the important information to help you solve that problem? Then once you have your plan, implementing it by doing the calculations, and then the last thing is second last thing is evaluate and verify. So did you solve the problem? Is your answer reasonable? What could you have done to ensure, or if not, go back and check your working out. And once you've got a solution that you think is reasonable, then you're going to communicate, so in the context of the problem. So here we go, and the last thing I want to look at is wastage is a word that is like for when you're accounting for the materials not applied. So if you think about it, if you're going to buy a and I was going to cut a cone shape out of it for, say, a dress. So here's my dress shape material. I'm going to get components of it where this stuff here, what I cut out, is going to be my wastage. So I have to buy, or I have to account for that larger shape, but I'm really just wanting this area. So that would be considered your wastage because you can't use it to actually create your surface area. So that's things that we're looking at. Or if you've got paint, like you might have spillage or the stuff that gets stuck in your roll and so forth. So that is what we mean by wastage. And then you've got finding the percentage of a value. Now this is a junior skill. However, it's always good to get a refresher. So your percentage button is on your calculator, or you can use percentages on your calculator. So 10% is 10 shift and percentage, and that'll give you your percent there. If you hit equal button, you can see that it is 0.1, but if you have forgotten how to do those conversions, you'll need to go back and have a look at some stuff. But if not, there's your percentage button. The word of just means to multiply. So essentially what you are looking at when you say find 10% of something is 10.1 times the value of that product. So here is our first question. A fruit cake is shown in the following figure. Divided equally among 100 people at a wedding reception. What is the volume of cake per, or will each guest receive? So you can see I'm kind of like staging it already. The question is asking you, what is the volume of cake each person or each guest is divided equally? And we can see each. So those words tell us it's going to be a division problem. Then you have also important information like your numbers. It's going to include your 100 guests or 100 people, and also the stimulus, which is your wedding cake here. So what we're going to do is devise a plan. You're going to calculate volume and then calculate per person. So let's do that. So what I can see here is that I've got a large rectangle or a square base prism and a large one and a small one. So I'm going to calculate my total volume. So TV equals the length, width, height of the big one plus the length, width and height of the small rectangular prism. And I'm going to substitute my values in. 40 times 40 times 12 plus 25 times 25 times 12. And the answer for that wonderful 26, oh, too many little wiggles. 26,700. and checking our units, centimeters cubed. So TV. The next thing I'm going to do is then work out per person. Well, that's 40 times 40, so there's like 200 just there. Times that by 12 gives us our big depth, and the same with that one there. So that sounds pretty reasonable, and what we're going to do next is calculate per person. So volume per person. I'm going to use my formula of volume equals the total volume divided by the number of people, and the V equals 26,700 divided by 100, so we're just moving that decimal place 2 places. So what I have then is that I've now got my volume. Does that sound reasonable? Yeah, well, it's 100 times smaller than the whole cake. And also I am going to give my answer in context of the problem. So have I answered the question? Yes, I've got the volume per person in cubic centimeters, and it's the larger cake. So that's that one there. The next one, so here we go. We've got a question here. Hagrid needs to recover a greenhouse, or recover the greenhouse shown in the diagram. So that's our stimulus there with some numbers. Assuming that there is 15% wastage for cutting and sewing, calculate the total surface area of the greenhouse. If the greenhouse material costs this much, $7.65 per meter, calculate the cost to recover. So the first thing we're looking for is what's the question asking us to do. That's calculate total surface area, and the second question is calculate cost. So we have some important information. So our stimulus, we're going to assume that there's 15% wastage, and it's $7.65 per meter. So that's going to help us out as well. So my little plan I'm going to devise is 1, calculate total surface area, 2, wastage, and 3, I'm going to be calculating the cost. So 3 steps. So the first step is this total surface area, and what I'm going to be looking at is how can I break this down into components. So what I can start to see here is if I was going to open this up, I'm just going to draw that over here, you'll see that it is a rectangular prism and a triangular prism. So on the rectangular prism, we don't actually have a top and bottom because it's a part of the greenhouse, and we're not going to be like covering those components there. So we can like remove them from the formula, so we don't need to look for those. However, we do need to look for the other 4 sides. So I'm just going to call that 1, which means that this is a 1. 2, which means the 2. My triangles at the front I'm going to call 3, for the one at the back is 3, and these 2 slope sides are 4 and 4. So I've got, this is a very nice easy shape. There's no Pythagoras involved because it already gives us the slope of the triangle and the height, so we can get straight into doing that. So what I've got here is my working formula, or my modified formula. I've got these 2 rectangles here, so that's going to be 4 and 5, so the 5 times 4 and the 2 at the front, because there's 1, 2 of them, plus 2 of shape 2. So the dimensions for that is 2 times 16 times 4, because that gives us that one there, plus 2 times L. So 4 is this slope shape here. So you can see that 10 is one of those measurements, times the depth of the shape, which is 5, plus our triangles. So you'll see that there's a divide by 2, times by 2, because there's 2 triangles, but divide by 2 because it's that's the formula for 1/2, one of those. And so what we can do is end up, it's going to cancel out anyway. So 2 bracket 3, our base is 16 times 6, which is the height, divide by 2, and those 2 will negate each other. So my answer for my greenhouse is greenhouse area is 364 meters squared. I'm going to take that surface area now and calculate percentage wastage. So to do that, I'm going to take 15% of. Now, if you think, break it down into, so to find total material, it's going to equal the original item, so the total surface area, and that's 100%. And we also want to find the 15%, which is wastage. So if we actually add those together, another way we can write that is 1.15. So my total material is going to be my total surface area multiplied by 1.15. And that'll give us 364 times 1.14. Our total surface area, total material required, including wastage, is going to be 418.2, 6 meters squared. Once I've got my wastage, I'm going to now work out my cost. So calculate total cost. And that's going to be total cost equals materials times meters squared, like the cost per meter squared. Ooh. And that's going to give us 418.6 times $7.65, and that will give us a grand total of $3,202.29. So that's our total cost. Does that sound reasonable? Well, yes, because 4 times 7 is 28, and I've got extra bits here, 1, 2, 3 numbers, so and then the 18, so that sounds all pretty reasonable, and that sounds reasonable too. I'm not making something that's palatial, and I would expect it to be quite expensive. 16 meters is like the length of a building, so it's quite a large glass house. So you would write your context and your problem. So I'll do that. Okay, so I've included my final statement here, making sure that I'm mentioning my total surface area, because that's what the question was asking me to do. Calculate total surface area, that's here, and also calculate the cost. So my final answer is in the context of those two questions. Total cost for the area, and it's going to be this much to spend. All right, well done. We've got some exercises here. Don't forget to do your homework. Thanks, everyone. Bye.